Students, in yesterday's lecture, we studied the standards associated with the vertical sync pulse and vertical blanking pulse, which are introduced at the end of every field of vertical redress. That is at the end of odd field as well as at the end of even field, to interlace both the field with each other and also to keep the screen blank during both the redress period, where returning beam doesn't contain any type of the picture information within it. Also, these are used to synchronize the transmission and reception with each other. We also studied the meaning of vestigial sideband, how bandwidth is reduced by using vestigial sideband technique. Students, today we are proceeding further to study the monochrome television receiver with the help of block diagram. Monochrome television receiver means it is black and white television receiver. It is a receiver that is tuned to the transmitting antenna, to the transmitter, and is capable to receive the picture information transmitted by the transmitter in the electromagnetic radiation. After receiving it, convert it into radio frequency signal, processes it, demodulates the signal, and make to display, produce the picture raster on the television screen so as to give illusion of the picture information on the television screen. Also, the audio signal to be obtained from the speaker. During this entire process, the monochrome television receiver makes use of super heterodyne principle. Thus, we can say monochrome, or it may be a color television receiver. It uses super heterodyne principle to pick up the television signal, that means audio as well as video signal, along with vertical and horizontal sync pulses and blanking pulses, that is known as composite video signal in VHF or UHF range. VHF means very high frequency and UHF means ultra high frequency range. To process it means received signal is processed, meaning thereby audio signal is separated, video signal is separated, vertical sync pulses, blanking pulses, horizontal sync pulses, vertical sync pulses, all those are separated and gets provided to the respective destination places within the television receiver. That is, detect from video and audio signal, then convert it into their original form. That means audio signal is converted to acoustic sound and video signal is converted into the picture information displayed on the television screen. That is known as the original form. That is the picture and sound signal. Such a device is known as monochrome television receiver, or it is in general television receiver. If it performs the process on black and white, it is called as a monochrome television receiver. If it performs the same function on the chromatic signal, then it is called as color television receiver. Friends, the outline of television receiver is represented in this particular block diagram, which is in front of you. If you look to this particular block diagram, it begins with the receiving antenna. Friends, we have studied details of the antenna in the topic of radio propagation and antenna. The output of antenna, it is given to the RF amplifier. Output of RF amplifier, it is given to the mixer. To the mixer, local oscillator frequencies provided. This entire block, including three circuitries known as RF tuner. Its role is to keep antenna tuned with the signal which is coming from the transmitter. The output of the mixer so obtained is given to the IF amplifier, which is common for audio video signal. After that, video signal is detected. Here, audio signal is bifurcated, video signal is bifurcated, and also horizontal and vertical pulses are bifurcated. Video signal is then given to the video amplifier. Audio signal is given to the audio section, especially to the sound IF amplifier, then FM demodulator, and audio amplifier. The output of the audio amplifier, it is given to the speaker. In parallel with that, video signal is given to the picture tube, and also the horizontal and vertical sync pulses are given to the scanning and synchronizing circuits. Means this is the circuitry that is used to separate horizontal sync and blanking pulses and then provided to the horizontal deflection system, whereas vertical sync pulses and blanking pulses are also separated and those are given to the vertical deflection system of the picture tube. Friends, picture tube is coated by means of a fluoroluminescence material on which high velocity electron beam containing the video's picture information is allowed to be incident with high kinetic energy and with high velocity because it passed through accelerating anode, main accelerating anode, pre-accelerating anode, focusing anode, control grid, vertical and horizontal deflection system with high velocity, high kinetic energy incident on that of the television screen. The fluoroluminescence material absorbs the kinetic energy, get it converted into the potential energy. It absorbs that and generates a bright spot that contains the picture information, and this bright spot is scanned, as which you already studied, scanned from left to right, horizontally and vertically from top to bottom, so as to give the complete illusion of the picture. Such a 25 frames are scanned within a 1 second so as to produce exact replica of the picture. Simultaneously, audio is produced in the speaker. Speaker converts audio electrical signal into its corresponding acoustic sound signal. Friends, this is in general the block diagrammic representation of monochrome television receiver. To study details working of the monochrome television receiver, we can say now. The receiving antenna, we will begin from receiving antenna. Receiving antenna intercept the electromagnetic radiation which is traveling from transmitting antenna in a space, get it converts the electromagnetic radiation into VHF, which are in the VHF and UHF range, into its radio frequency signal. This is because RF tuner, which is part of monochrome television receiver, it is used to tune the receiving antenna to the incoming transmitted signal. Then the signal is given the first block of the monochrome television receiver, that is known as RF tuner. It makes use of three blocks internally. One is RF amplifier, second one is a mixer, and third one is a local oscillator. RF amplifier is composed of several stages of the amplifier to amplify the incoming signal to the required voltage level. Almost all 40 dB signal is going to be get generated from the RF amplifier. Its bandwidth is so adjusted that it is going to occupy almost all the signals which are coming received by the receiving antenna. Not only that, RF amplifier accepts only wanted signal and rejects unwanted adjacent channel frequencies. It also reduces the high frequency distortion as it possesses the proper signal to noise ratio, so that signal power received by the RF amplifier will be more and noise will be less. To perform this action, RF amplifier makes use of series and parallel resonant circuitries. Series resonance circuitry accepts only the wanted frequency, and parallel resonating circuitry is used to reject the unwanted frequencies. The gain of RF amplifier is also adjustable. If the incoming signal is very weak, it is amplified more. If incoming signal has a proper gain, then it will amplify less. All these functions are produced by means of an RF amplifier. It might be B.Sc-III as an amplifier with the several voltage stages, multi-stage amplifiers. It may be FET as an amplifier. It may be last stage as a power amplifier. Thus, it produces the wanted signal frequency, say Fs. This Fs signal frequency is given to the mixer. Mixer contains the diode devices along with the passive components network, so that the received one of the signal, that is signal frequency, and another signal from the local oscillator, both are compared here. After comparison, at the output, 4 frequencies are going to be generated. One is signal frequency as it is. Second one is the local oscillator frequency as it is. Third one is sum of these frequencies. And fourth one is difference of these frequencies. Friends, as a being next stage is IF amplifier, we are interested here the difference in two frequencies. That is the difference between local oscillator frequency and also the signal frequency. The difference in these two frequency is called as intermediate frequency. The IF amplifier has got the same bandwidth as the output of mixer generates the intermediate frequency band. Friends, the local oscillator which is used in tuner is maybe Hartley oscillator or it is Colpitt's oscillator that generates the radio frequency output. Please do remember that local oscillator frequency is always greater than that of signal frequency, and local oscillator frequency is adjustable one. Depending upon signal frequency, one can change the local oscillator frequency, so that always IF of the output of the mixer stage is going to be remaining fixed or constant. So that same IF will be accepted by the IF amplifier. One can say IF amplifier is designed for the same IF frequency, so that only that will be received. Rest of the frequencies are automatically rejected. So that frequency is amplified here, which is common for audio as well as video signal. But friends, in this case, a video signal is amplified more than that of audio signal by 5 to 10%, because audio and video is required to be separated in the next block. to keep their individual identity, this process has been adopted in this particular IF amplifier. For that particular purpose, the gain of IF amplifier and gain of RF amplifier is also automatically controlled by using automatic gain control unit. Thus, here only the bifurcation of audio and video signal starts. Friends, this amplifier also contains cascaded stages of the B.Sc-III amplifier or FET amplifier, or maybe in present days it is integrated circuit as an amplifier. Thus, output so generated is given to the video detector. Video detector makes use of some filter circuitries also, or trap circuitries also. These trap circuitries traps the audio signal, which is 5 to 10% less amplified, and separates audio and video. Here, video signal so separated is demodulated. As we are aware that video signal is amplitude modulated, by using envelope detector, one can separate the carrier frequency from that particular original video signal, and so generated video signal now contains the sync pulses and video signal. Those sync pulses are also trapped and separated. Separated sync pulses are given to the scanning and synchronizing circuitry, whereas only electrical signal proportional to the picture information is given to the video amplifier. Simultaneously, a trapped audio signal of 5.5 MHz is given to the sound IF amplifier. This sound IF amplifier is designed only to accept the IF of 5.5 MHz. After amplifying sound signal here, it is given to the FM sound demodulator. As a being, sound signal is frequency modulated, as we are well aware. At the beginning of the television receiver only we have studied that sound signal is frequency modulated, whereas picture signal or video signal is amplitude modulated. So that's why to detect the sound signal, discriminator circuitries are used here. Maybe it is a ratio detector or it is a Foster-Seeley detector that detects the audio signal, separates the carrier wave from that, and only audio electrical signal is given to the audio power amplifier. Audio power amplifier may be a push-pull power amplifier or complementary symmetry power amplifier that amplifies the power level of audio signal, and so amplified power level audio signal it is given to the speaker. When audio electrical signal comes to the speaker, meanwhile synchronizing pulses are separated into horizontal and vertical sync pulses, and those are applied to the horizontal and vertical deflection system of the picture tube, which are introduced at the end of every horizontal trace and also at the end of every odd and even field where the vertical retrace begins. Simultaneously, video signal applied to the video amplifier, its power level is again amplified. Then it is given to the picture tube in the electron gun assembly. Electron gun assembly contains heater for the cathode, which is heated indirectly, to which this electrical signal is given. Cathode emits the electrons proportional to that of the picture information which is present in the output of the video amplifier. It is passed through the control grid that controls the flow of electrons and passes it to the pre-accelerating anode, where electron beam is accelerated. Then it is passed to the focusing anode, where somewhat scattered electrons are existing. Those are made to be converted into the beam of electron. Then so generated electron beam is passed to the final accelerating anode or main accelerating anode, where electron beam velocity is increased so that it possesses the high kinetic energy. Then it is passed through the horizontal and vertical deflection system, to which the horizontal and vertical sync pulses are already applied. This high velocity, high kinetic energy electron beam containing the picture information is allowed to be incident on the television screen, coated by means of an fluoroluminescence material. When high velocity kinetic energy beam, electron beam containing the picture information is allowed to incident on the screen, it absorbs the kinetic energy, get it converted into potential energy, and then it emits a bright spot in the form of a light radiation. That spot is known as pixel of the picture. Simultaneously, horizontal and vertical deflection system starts scanning the spot from left to right of the screen, horizontally and vertically from top to bottom, where 625 lines are scanned so as to from one vertical frame that carries two fields. One is odd field, that is 312.5 lines. Another one is a even field. Both are interlaced with each other, and on the television screen the picture raster is generated, which is the same as that of the camera snapped scene or event, which is reproduced on the television screen. When picture is reproduced on the television screen, simultaneously speaker converts audio electrical signal into acoustic sound signal, which we can listen by our eyes. So that simultaneously one can watch the picture on the television screen and also hear the acoustic sound signal, and one can enjoy the information produced on the picture too. Friends, this is how the monochrome television receiver works. Let us see description line by line. RF tuner, television signal picked up by receiving antenna are in UHF and VHF range and are very weak. These are fed to tuner via balloon. Balloon matches the impedance of antenna and receiver in a ratio 4:1. RF tuner contains the RF amplifier and its front end followed by the mixer, to which the output of local oscillator is also fed for frequency conversion. Already we have studied it. It is presented in the block diagram also. The shielded unit, commonly termed as a RF tuner, to avoid the interference and noise picked up by means tuner avoids the interference between noise and picture. The RF amplifier has a large bandwidth, almost of 7 MHz, that is equal to the vestigial sideband, which is being transmitted by the transmitter, so that all signals in a video channel get amplification. The gain of mixer is controlled by AGC obtained by video detector, RF amplifier and the local oscillator. Two signals beat with each other and produces the difference in frequency at the output of the mixer that contains the picture and sound modulated along with two IF carrier. The picture IF carrier of 38.9 MHz, sound IF carrier of 33.4 MHz are produced. Fine adjustment in local oscillator is carried out by tuning the control. The output of tuner is fed to IF amplifier to reduce noise picked up. So friends, after that, try to remember the RF amplifier uses the super heterodyne principle. After that, there is a vision IF amplifier. IF obtained at the output of the mixer has a very low amplitude of the order of few millivolt or less. Vision IF amplifier is designed to provide high gain of 40 dB to 80 dB. It provides the amplification to sound signal only 5 to 10% of the picture signal amplification. This is achieved by using sound trap circuit in Vision IF amplifier. Now video detector. A linear diode detector circuit is employed for detection of the Vision IF signal obtained by video signal lying in a range of 0 to 5 MHz and the frequency modulated sound signal at 5.5 MHz. The carrier frequency and harmonic components are filtered out. From the output of detector, inter-carrier sound IF of 5.5 MHz is obtained by beating sound signal of 33.4 MHz with the picture signal 38.9 MHz. Are filtered out. From the output of detector, inter-carrier sound of 5.5 MHz is obtained by beating sound signal of 33.4 MHz and picture signal of 38.9 MHz. The difference 5.5 MHz contains FM sound and blocked from the video signal by using the sound trap circuit and passed only to the sound circuit. Next one is a video amplifier. The video signal detected from the detector is very small and must be amplified by one or more stages of the amplifier. Stages to drive the picture tube, which requires the signal between 40 holes to 80 holes to produce good picture. Video signal is given between cathode and grid of the picture tube in a manner that the signal corresponds to black level, cut off the electron beam from the reaching the screen, resulting a black region. In addition, DC bias is provided to the control grid, which is controlled manually by potentiometer known as a bright control that controls the average beam current. It also controlled by controlling the gain of amplifier. Then sound circuit. It contains the sound IF amplifier that amplifies 5.5 MHz frequency modulated sound signal and has adequate bandwidth for the purpose of limiting noise. FM signal with constant amplitude is then fed to discriminator circuit, that is a ratio detector or Foster Seeley detector, for obtaining audio signal. This signal is amplified by the audio amplifier to required voltage being fed to push-pull power amplifier that drives the speaker to get the sound. Friends, now last one is horizontal and vertical deflection system. A part of video signal feed to sync separator, which is represented in the block diagram definitely, which clips the 70% of the picture signal portion so that only sync pulses are available at the output, which are fed to the differentiator and integrator circuit. In the block diagram, it is represented by horizontal and vertical scanning circuitries. That includes all these aspects. The output of differentiator are narrow spikes at horizontal frequency and used to control the frequency of the horizontal oscillator. The output of horizontal oscillator is fed to line stage that produces the sawtooth current that feeds to the horizontal deflection coil to produce the horizontal deflection. Thus, integrator produces the pulses of the vertical sync. Pulse sequence used to drive the vertical oscillator generates sawtooth pulses given to drive the vertical deflection coil to produce the vertical deflection. The vertical oscillator generates the sawtooth pulses given to drive the vertical deflection coil to produce the vertical deflection. Thus, intense bright spot scans horizontally and vertically to produce the raster and gives the illusion of the picture on the television screen as seen is snapped by means of an camera. Friends, this is how the monochrome television receiver works, processes the signal which is being received from the transmitter and get it produced in the form of the picture raster on the television screen and also acoustic sound signal at the speaker. Next time we'll go for the color television receiver with slight changes in this particular block diagram.